All right, my friends, let's do some more logic. We're continuing our study of natural deduction and doing proofs. And we're going to learn the rest of our inference rules today. Our next rule is called simplification. And it just means if you have something that's true and true, you can break down either side of it. Right? You could do a truth table for it if you wanted to, and you'd see that it's valid. So if you have P and Q, you can infer P. If you have P and Q, you can infer Q. The truth value is preserved. And again, it's a matter of form. And this is what you call an AND rule. Right? See? So whenever you've got anything joined with an AND, with that ampersand, you can break off either side of it and use it in your proof. The other rule is called conjunction. If on one line you have P and on another line you have Q, then you can conjoin them and make it P and Q. So for example, if I had on one line, if A or B then C, and if I had on another line M, I could join them together. A or B then C and M. So let's think about how we might use these words. Consider this argument I once presented to myself when I was 14 years old, when I bought a new Dylan album. New clothes are good, but music is better. And I will buy the new Dylan album if music is better. So new clothes are good, but I will buy the new Dylan album. So there's my dictionary, and we translate it, right? First premise is N and M. The second premise is if M then B. Remember, the if in the middle, right? So that means if music is better, then I'll buy the new Dylan album. And the conclusion is N and B. Okay? And if I go looking at this, right, I'm looking for, I can see if I had an N by itself and a B by itself, that I could get N and B and join them together with our new rule. And I see I have an N right there, right, and an M, right? And I see I have a B here. So I could take that M by simplification from 1, and then 2 and 3 would give me B by modus ponens, and then I get an N by simplification, and then I can use my new rule of conjunction to put N and B together, and I've gotten from these premises to that conclusion using the rules. You also want to note here 2 important restrictions on how we may apply these inference rules. First, again, the rules may only be applied to a whole line in a proof. Second, the rules are asymmetric. They're what we call one-way rules. So if you had A and B, you could infer B, but given B, you could never infer A and B. If you don't believe me, do a truth table and see how it would turn out. Our next rule is called addition. If I have P, I can join anything I want, essentially, to the other side of it. And if I have a Q, I could add a P. Let's look at some instances of this. If I had a J, I could add, if I wanted, if S then M. Or if I had, if A then B or C, I could join to it, if I wanted, D and F. Let's see how we would use this in a proof. Suppose I argued, life is full of wonder and life is full of terror. Therefore, either life is full of wonder or I lack the wit to see it, and life is full of terror or I am too comfortable to notice it. So I have a one-premise argument, W and T, and I want to get to W or L and T or C. Now using the rule of addition, see how I could do this. I can use simplification and get a W, and then I can use addition to get W or L. I can then break out the T with simplification and use addition to get T or C, and then I could join those 2 lines together. Now, addition may seem like a strange rule. It almost seems like pulling a rabbit out of a hat. I could just put a V and put whatever I wanted on the other side. But think about it in terms of the meaning of the operator. Basically, this rule says that if you have a true statement, then whatever you can join, true or false, the statement as a whole will be true, right? So if P is true, then it doesn't matter, right? Or if Q is true, you can add whatever you want and the truth value will be preserved, which is really what the rule is all about. And again, you could do a truth table and prove this to yourself if you're doubting me. Our last rule is that old favorite of the philosophers, constructive dilemma. If P then Q, if R then S, P or R will give you Q or S. And think about an instance of this form, because remember, the P and the Q are just like blank spaces. You can plug in anything you want. So here, P then Q. That whole thing's the P, and that's the Q. And then we have R, and then we have S. And then if we had P or R, we could get Q or S. Okay? You want to mull this over and think about it. If you can't see it clearly, stop the video, look at it. Or if it helps you, instead write it out and draw boxes and a circle and a triangle and an oval. Whatever helps you sort of get into seeing the patterns is important to do. So just think about this rather complicated sounding argument. If Socrates is convicted, then he's faced with a dilemma. Either he dies in jail or he escapes into exile. But he is convicted if and only if he gives up the practice of philosophy. If he dies in jail, then he faces the uncertainty of death. If he escapes into exile, then he betrays his principles. So either he faces the uncertainty of death or he betrays his principles. Now, if we translate this, see, we have 1, 2, 3, 4, 5 lines, right? 5 lines for our premises, and there's our conclusion. But notice, it only takes one step to prove it. Let me explain. Here's the form of constructive dilemma. And we're looking for patterns, right? We're looking for patterns. And when I'm looking at this proof, I'm thinking, I've got a couple of conditionals, and I've got a disjunction. So think about it. D, then U. E, then B. D or E gives me U or B. See, you have to be able to sort of twist your head around like falling down the rabbit hole with Alice, sort of think backwards and upside down. But you still, if you pay attention, you can see the patterns. So maybe pause the video and stare at this for a while and see what you make of it. And then another one just for fun. This is one we've translated before. Philosophy being simple is a necessary condition for wisdom being easy to come by. But life is confusing, and philosophy is not simple. And questions multiply faster than I can answer them if either life is confusing or downright perplexing. And questions multiply faster than I can answer them only if I'm often confused. Therefore, wisdom is not easy to come by, and I am often confused. So first, we just translate the thing. And then we have if E, then S, C and not S, if C or D, then Q, if Q, then O, therefore not E and O. Let's just try to think through this together. I'm looking for a not E and an O, right? And so I go looking for patterns that can help me, right? I realize, remembering my rule of conjunction, if I had a not E and an O by themselves, I could join them together. So I go looking first for a not E. How could I get a not E? Well, here's an E then S, and if I had a not S, I could get a not E. Well, I can get a not S, so let's make a start. So I can get not S, and I got that from line 2 by simplification. Now that I have the not S, I can get the not E from lines 1 and 5, modus tollens. So I have a not E, now I need an O. There's an O right here on line 4. I could get an O if I had a Q. There's a Q there, which I could get if I had a C or D. And I could get a C or D if I had a C, and I can get a C right there. So let's simplify that C from line 2. Now that I've got the C, I can use my funny rule of addition to get C or D. With a C or D, I can get my Q from line 3 and 8, modus ponens. And now, with the Q, I can get the O from line 4 and 9, modus ponens. That modus ponens is a very useful boy or girl, depending on how you look at it. Now that I have an O, I can go not E and O, and I've got that from line 6 and 10, conjunction, and then I just want all my little citations to line up neatly. So I'm going to do that. And I'm done. I've gotten from these premises to that conclusion by the method of proof. So that's it for part 2. Like I said, I'm doing this in little bite-sized bits so that we don't choke on them as it all goes down too quickly, so to speak, metaphorically speaking. So I'll see you shortly. I'm about to start recording another video. Thank you for your kind attention.